Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problems involving various data structures such as arrays, trees, linked list, and also programming paradigms such as breadth first search, depth first search, dynamic programming, union find, and so on. Please check them out. I have uploaded the code for this particular problem to the GitHub repository. You can get the link from the description below this video. Let's jump into today's problem. Possible bipartition. Given set of n people numbered 1 to n, we would like to split everyone into two groups of any size. Each person may dislike some other people and they should not go into the same group. So that's the condition. So we have n people numbered from 1 to n and we have to divide all the people into two different groups. So each person could dislike 0 or more persons, right? So the input given is dislikes of I is equal to AB. It means it is not allowed to put the people numbered A and B into the same group. So we are given with a dislikes array, okay, where the array will have the entity in the array will have two numbers, A and B. So A and B don't want to be in the same group basically. So return true if and only if it is possible to split everyone into two groups in that way, right? So let's try to understand through the example, right? So basically dislikes is one input and n is equal to 4. So that means there are 4 people and dislikes array given as, so 1 dislikes 2. So that means 1 and 2 cannot be in the same group, and 1 also dislikes 3. So 1 and 3 also cannot be in the same group, right? So 1 and 2 cannot be in the same group, 1 and 3 also cannot be in the same group, and next 2 and 4. So 2 and 4 cannot be in the same group, like that. So this is the input and we need to, the expected output is true for this. So the explanation that given is you put 1 and 4 in one group and 2 and 3 in one group. So if you go back and look dislikes, right, 1 and 2, so they should not be the same group, right? Yeah, 1 is in group 1, 2 is in group 2, good. 1 and 3, 1 is in group 1, 3 is in group 2. 2 and 4, 4 is in group 1, 2 is in group 2. So that's how the segregation into two groups basically. So for this particular input we would return the answer as true. So we are given with two inputs, right? So we have n people and each person may dislike 0 or more people, right? For example, it is like two-way relation, right? So 1 dislikes 2, that means 2 also dislikes 1. So essentially 1 and 2 will not be in the same group. So that's what we need to understand. So 1 dislikes, even though 1 to 2 is given, right? So 1 dislikes 2 and also 2 dislikes 1. That's what we have to think, because that is not given in the information here. So it's just given that okay, 1 dislikes 2, right? So that means 2 also dislikes 1. What that makes is they don't want to be in the same group, right? So that's what it is. We need to understand like that. So let's go with an example and try to do the algorithm way, right? So let's take an example. So here 1 2 3 4 4 5 3 5. So in this case n will be 5, okay? So n is equal to 5 and we have 1 2 3 4 4 5 3 5. That means 1 dislikes 2, 3 dislikes 4, 4 dislikes 5, 3 dislikes 5. So even though we are given this, right, so there are opposites also we need to make. So 2 also dislikes 1, even though that is not given here, that is implicit. We need to understand that way, right? So let's try to prepare a dislike map, right? So that's what I have given here. So 1 dislikes 2, right? So from 1 to, so one more thing is 2 also dislikes 1, even though it is not mentioned here, we need to put that into our dislikes map, right? So that's the key here. So 1 dislikes 2 and 2 also dislikes 1, put that also into the map, right? Yes, and then 3 dislikes 4, 4 also dislikes 3. So 3 dislikes 4 up till this. So 5 will come and 4 dislikes 3, right? So let's put 3 here, right? And 4 dislikes 5. So 4 dislikes 5, right? And 5 dislikes 4. 5 dislikes 4. And then 3 dislikes 5. 3 and 5. And 5, let's put 3 also. So this is the complete dislikes map, right? So now that we know who dislikes whom, right, we will go through each of these and try to put them into groups. We just have to put only 2 groups, right? So now let's go with the person 1, right? So 1 dislikes only one person. So 1 and 2 should be in the different group. So what we should do is put 1 into G1 and 2 into G2, right? So that's what we are going to do. So put them into different groups. And then next go 2, right? So next go with 2. 2, what we are trying to see, so 2 is already in group 2, right? And then that means the people who disliked by 2 will be in group, should be group 1, right? So the people disliked by 2 are just 1, but 1 is already in group 1, right? So that's good, right? So 1 and 2 they have already put into the groups, so we don't have a problem for that. And then 3, so 3 dislikes 4 and 5, so 3 should be in one group and 4, 5 should be another group. Let's say 3 goes to group 1 and 4 goes to group 2 and 5 also goes to group 2 because 3 dislikes 4, 5, right? So now we prepared that. Now since we have to go and do it recursively, right, we will take 4 now. 4 dislikes 3 and 5. So 4 in which group? Group 1, right? 4 is in group 1. So 4 is 3, right? 4 is in group 1. Sorry, group 2. And for 4, that means 3 we should put in group 1. So let's see if 3 is in group 1. Yes, 3 is already in group 1. And 5 also we need to put in group 1. But 5 is already in group 2, right? So 5 is already in group 2. So one person you cannot put in group 1 and group 2. What happens in that way is, so there is a conflict, right? So 3 we can put in group 1, no problem, because 4 in group 2. But 5, we are saying 4 doesn't like 5, 4 and 5 should be in different group. But we already put G1, G2 for 4 and 5 because of this relationship, right? 3 doesn't like 4 and 5. So there is a conflict between 3, 4, 5, right? That means we cannot make this as a bipartition group. So we will return false, right? So let's go with an example, example 1 where we are returning true, right? So we'll frame the similar dislike map and go through that, right? So let's prepare a dislike map for this one. So here n is equal to 4, that means, right? That's what the input given, right? N is equal to 4, right? So for 1 dislikes 2 and 3. So similarly 2 also need to be added 1. So this is 1. For 3 also we need to add 1, right? So for 2, 4. So 2 you add 4 and for 4 you add 2. So now start with 1. So 1 will be in group 1, 2 and 3 will be group 2. Next go to 2. 2 is in group 2, that we know already. So 1 should be in group 1. Yes, 1 should be in group 1. Put 4 also in group 1. Okay, let's put 4 also in group 1. Yes. So now let's put 4 in group 1, right? Good. That's good. And then go to 3, 1. 3, 1. 3 is in group 2. 1 should be in group 1, right? Yes, it is the case. 4. 4 in group 1, 2 in group 2. Good. So they are all can be in 2 groups. Essentially 1 and 4 in the one group and 2 and 3 in the second group. So since it satisfies our basic logic, we will say for this the answer will be true, right? So that's the approach that we are going to see. So first you need to prepare the dislike map and then go through each person and recursively see if there is a mismatch between the group assigned. Okay, let's go jump into the code. Okay, so now I have a map where each person could dislike n number of person, right? So that's why I have a map, and this is groups for which person which group is assigned. Okay, so I have group 1 and group 2, right? Good. So map and group are initialized, and get the length of the dislikes as m, okay, and put a new hash set for each of the persons to put all the disliked people, right? So now we go through all the dislikes and put into the map who is disliked by whom. So basically you have from and to both, right? So you put from to 2 and 2 to from. Basically if you have just 1 and 2, right, what it's doing is in one's map put 2, in 2's map put 1, like that we are doing. So this is an essential step. So from the input it looks like we have to only take this one, but even the reverse also we need to put. This is essential, right? So this is essential, important, okay? And then now that we have formed this map, we will go and assign group to each of these persons. Now for I is equal to 1 to n, basically the numbers are numbered from 1 to n, right? So that's why we are starting with 1 and going less than or equal to n, not from 0 like we start in regular ways, right? So now what we are saying is if groups doesn't contain I, so that means if somebody is not assigned a group, then only we will go, right? So if the person 1, is he assigned a group? No. Then only we will go enter. If he is already assigned to the group, right, we don't have to worry. So now we are saying, okay, this person is not assigned to group, and see all his dislikes are in a different group or not, right? So if all the persons disliked by I are in different groups, then we are good. So means I and its dislikes, basically I am calling them as neighbors, right? So dislikes, let's call, right, dislikes belong to different groups. If so, we are good, we don't have to do anything, but otherwise we return false. So another way to write is just put a not symbol here, if so return false, but this gives like better readability, that's why I am giving you like that code, okay? And so now what is this DFS is actually doing, right? That's the question we need to answer. Go into the DFS function. So it says, okay, for this person is in this group, check if the neighbors or the disliked people by I are in the different group or not. That's what the question is, right? So now if I is in group 1, that's what we are saying, right? I is in group 1, so this is a group ID. I am putting I into group 1, so whatever the people that are disliked by I should be in group 2, right? That's essentially thinking. So now, so groups of add I group ID. So now I am saying, okay, group, this person is group 1, okay, whatever the group is, and whatever the dislikes by I that we have been mapped, right? So they should be in group 2. So that's why I am passing. If group ID is 1, they should be in group 2. The group ID is 2, they should be in group 1. So that is what I am checking recursively, right? So this one is getting recursively. So finally, if any of them doesn't match, right, we should be returning false. Otherwise, finally we return true. So that's how we are going to go and perform in a recursive operation to see, okay, if X is in group 1, people disliked by X should be in group 2, right? Likewise. So that's what it is. So let's go ahead and look at the time complexity and space complexity for this particular problem, right? So we are saying the let me write time and space, right? So we are saying there are n people, right? N people, and we are saying m dislikes, right? M dislikes, right? So that's what I am getting, right? M dislikes, and there are n people that was given anyway. So what is the time complexity here? Order of n, right? To put the map, so we'll put order of n for that, order of n, and how much we are taking for this to build the map, order of m. So that will be order of m, right? And then we were going through order of n again, right? So this would take order of n again. So totally order of n, I will say. And for each person, we are trying to calculate it recursively through the DFS, right? So we don't know the recursion length, but what we can guarantee is each person will be looked at only once, right? Each person will be looked at only once, right? So what that means is, even though this DFS is going through like several recursive calls, for each person we are doing only once, right? So it appears that the DFS is going a long way, right? So all the recursions for a given person dislikes and their dislikes and their dislikes and their dislikes. But this is making sure you are doing only once, because once you have a person assigned to a group, it is not going to change, right? So that's the reason why we will say, okay, even though this is getting called recursively, the total time complexity for this will be still order of n. So what does that mean? The overall time complexity will be order of 2n plus m. So since we are going to remove all the constants from the big O notation, we will say order of n plus m is the time complexity. So what is that n and m? You need to remember that n is the number of people, m is the number of dislikes, right? Good. So now let's get back to the space complexity. Are we using any extra space here? Yes, we are using map and we are using groups, right? So what is the time? What is the space in the groups? Groups will be equal to the length of the equal to the number of people, not length actually. Groups is just, we are initializing n, right? Groups will be n, right? So order of n space. And what is the map it is going to take? It is going to take, again, we are going through number of dislikes, right? We are going through n number of dislikes, but as we are building through the number of dislikes, there can be n people disliking everyone, right? So if there exists a person which doesn't dislike anyone, that's a different case. But what is the worst case complexity? Each person disliking at least one more other person, right? If you have n people, each person at least have one more dislike, right? That means every person has one dislike. So what is the complexity that we need for map? It is also order of n, right? So each person having some dislikes. So in that case, how many dislikes we will have? So it will have order of n into some number of dislikes. We don't know that, right? How many dislikes? Let's say d. I don't know that, right? It could be anywhere from 0 to n minus 1, right? D can be anywhere from, so d can be anywhere from 0 to n minus 1, because one person is himself, so he can like or dislike himself. That is a different question, but the thing is he could dislike all the rest of the persons, right? So that's the reason why we need order of n into d for map, right? So we don't know this d constant as of now, right? So the overall time complexity, we will leave it right there, right? Space complexity, order of n plus order of n into d. I would leave it right there, as I don't know the complexity for d, right? So that's how we are able to solve the problem of possible bipartition. If you still have any further questions, right, please post them in the comment section below this video. I'll get back to you as soon as I can. I have posted the code to the GitHub repository in two languages, C# and Java. You can find the link in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe. Also, share among your friends. Please click on the bell icon so that you will be notified about all my future videos. You can share my individual video as well, not just the group or the channel. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.